Alright, so last time when we covered conditional statements, we covered if-else. And if you want to review that, go ahead and check out the video. But today we're going to cover switch. So switch is also a conditional statement, but basically switch considers a value and then it tries to match it to a set number of cases, well, cases that you set. And then if there is a match, it will execute the code associated with that case. And then if there isn't a matching case, then we'll have a default code just in case it doesn't match any of the cases that we set. So it's kind of like an else statement where everything else that doesn't match the if applies. Now, a default case is not necessarily mandatory if you've accounted for every value, but if you haven't, then it's pretty smart to actually include a default case. All right, so let's see how to set that up. So let's go ahead and let's work with, I don't know, generations. Because there's, Generation X and Y and Z and baby boomers and whatnot. So let's have some fun. So let's go ahead and create a variable and we'll give it birth year. And birth years are years in general, are ints. You can't have like 1995.5. You can't have 2016.2. It's not accurate. So let's do 19. Let's say 80. Why not? And then we're going to have a string, which will allow us to type, to actually have some, have a message that will output what the generation is. All right, so let's go ahead and do our first switch statement. So we first just go ahead and type in switch, pretty easy. And then we type in the variable in which we are going to evaluate. In this case, it's going to be birth year. And then we do a bracket. And then we enter our cases. So the first case we're going to do, first case we're going to do is 1928. Now, I know this isn't accurate because usually generations encompass a set number of years, but bear with me. We're going to cover how to do that. So the first case we're going to say is generation string equals post-war cohort. I did not know this. I found this out. So if you ever want to know people who were born around 1928 to 1960 something, I don't know, 1930 something. Yeah, it's generation cohort, post-war cohort. Pretty interesting. All right, so our next case is going to be 1963. Generation baby boomers. And new case. I can spell case. 1955. And generation I think I have that wrong. It's 55 here, 1963 here. And we'll do Generation Jones. Maybe I flip those around. But anyways, just work with me. So 19... let's say 66, why not? This isn't totally accurate, people, it's going to be accurate enough for what we need to do. So generation X, in case 1977, generation y. All right. Okay, we're going to stop there. And then we're going to do our default because we have a lot of years that do not apply to any of these cases. So we want a default message that says this year isn't associated with a generation at this time. Okay. All right, so this is a switch statement. We have a switch keyword, birth year, which is the value, the variable here that we are evaluating. If you notice, kind of underlined. And then we have our cases in which it will compare birth year to, and if it matches, then generation string will output this message. You see generation string up here is highlighted as well. Okay, so let's play around with this. So we see here 1980, the year that I assigned birth year to, is not associated with the generation. And let's actually do a print generation string just so that we can see it in the debugger. Alright, so there you go. It's not associated with this generation. Alright, so there we go. The next thing, let's see, we're going to cover is switch statements with multiple values, which is what we need because we have so many years that are not accounted for that we need to add them. So one way to do this is to actually include individual values, and how you do that is you go into the case statement, you add a comma, which is a version of and say 1929 and 1930 and 1931. You get the point. So you can also do that, and if any of these values equals the case, then it's going to output post-war cohort. So if we do 1929, it will output post-war cohort, or if it's 1931, same deal. So there you go. So that's one way you can do it. Another way you can do it is range mapping. Now with range mapping, we use an operator. So the first operator we're going to use is 3 periods, and then we add the end value that we want to evaluate, or we want it to check against. So let's do 1955. Okay. So this will include 1928 to 1955, including 1955. So the triple periods is considered a closed range operator, so it includes X and Y, so it includes 1928 as well as 1955. So a great way to see this in action is I'm going to actually do a couple of, I'm going to finish up the last little bit here. So we do 1962, and then 1966, and 1976, and 1994. Okay, so I guess the best way to show you the difference between a closed operator and a half open operator, which here I'm going to actually put a half open operator. So as a comment, we're going to have, this is a closed range operator, and then we also have the half, which is 2 periods and a less than sign. This is a half open range operator. So the closed range, it includes both values of the range. A half open includes the first but not the second, so it does include 1955. And the way to see this is to actually use fallthrough. So fallthrough is it's a control transfer statement. So when you use fallthrough, it basically modifies the order of execution, and it transfers control or hands off control to the next case underneath it. Otherwise, what the switch statement will do is once it finds a match, it will actually pop out of the switch statement. And a fallthrough will say, yeah, you found a match, but I don't want you to pop out of the switch statement. I want you to go to the next one. So it'll evaluate the next one as well. So in this case, we have 1931, right? Which will output post-war cohort. And then, actually, let's do 1955, because this is, it'll pop out baby boomers. And you see 1955 up here was not included because it's a closed range operator. But if I made this it was half open operator, but if I make this a closed range operator, it will actually output post-war cohort and baby boomers. And of course it'll output the last value that was saved to generation string, which is baby boomers. But if you look at how the operation jumped from post-war cohort to baby boomers, you see that it actually fell through to the next case. Now if we comment this out, we see that it only outputs post-war cohort because it matched the first case that it came across, which in this case was the first one. So again, fallthrough is one of those things where if you want something to actually evaluate to the next, you want to control how the switch statement behaves, you use fallthrough. And there's actually more control transfer transfer statements, which we've come across, which I've actually used a couple of times. For example, return is actually a control transfer statement. Break is another one, and there's fallthrough. I'll go into more detail about all of them, so you can have all of them together, but I just wanted to make a note that there are more than one. But this one in particular is pretty awesome because with switch, you can still stay within the switch statement. So again, we have half open range operator, closed range operator, in which we can include or not include certain values, right? So the next thing we are going to cover, let's make sure I covered everything for this. So we went to the transfer statements. All right, we went through range mapping, which is awesome. So we are going to go over where statement. So a where statement allows you to check for additional conditions within a statement, but it kind of acts like a sort of dynamic filter within a switch statement. So let's see here. Let's filter this so that we can evaluate those years that we didn't account for. Instead of just having, oh, this year's not associated with the generation, we can actually get more in depth. So first thing we do is we create a case, and we do let unknown year, which is any year that's not accounted for, where, and then we add our conditions. Unknown year is greater than equal to 1927, because we didn't count anything that's, beyond 1928, right? As well as any years after 1994. Oops. Sorry, wrong button there. No year is less than equal to 19, oops, less than equal to 1994. Right, so then we use our colon because it's a case statement, and then we say, actually we're going to have generation string that the year is not associated with the generation because it isn't, right? And then we can just use our default as maybe an error check, right? So an expected value entered. Okay, so let's test this where statement. I'm gonna actually make a note here that this is a where statement. Actually, I'm gonna move this over here, right above, so we can see that we actually have a where statement there. And let's test this out. So let's say if we made birth year, oh gosh, 1927. Let's see what happens. And there you go. This year is not associated with the generation at this time, which is completely accurate because we didn't account for it in 1927. Let's say we did 1995. Actually, it should be 1995, actually, not 1984 because we have it up here. And again, this year is not associated with generation at this time. But if it's 1994, then it should output generation Y, which is completely accurate. So as you see, there is a way where we can test to say, okay, the year is between this and that, and we have, you know, an actual case that kind of encompasses that, and then anything else outside of that will generate a default. All right, so we covered that. So another thing I wanted to cover is tuples, and tuples are just awesome, in my opinion. Plus, they're fun to say. So tuples are basically logical related group of values that to the developer makes sense, like logically makes sense, and he or she will create a compound value of these, you know, 2, 3, however many values into one compound value, and it results in a ordered list of elements. So the best way to show this is to show it to you. So for example, let's keep with the generation thing. We have a, let's say, let generation group equal, let's do birth year, and then generation string, right? So now we have the birth year and what generation they are. Because I mean, this actually makes sense because, you know, we just don't want to know the year and then you don't know the generation. It'd be nice to have one variable in which you have both values in them, right? So one way to access these values is by indexing. It's really similar to arrays, and if you're not familiar with arrays, check out the video. But it's really similar in that the indexing portion is. So say if I want to know just the birth year, you can use generation group dot 0, and that is the index. So if you look over here, we have 0.0 equal 1994 and dot 1 equal generation Y. So by taking index of 0, we are saying we want the value at index 0. In this case, it's 1994. Now say if we wanted the generation, so generation string, we do index 1, which will pop out generation Y. Oops, sorry, generation group. Love that error. All right, so there we go, generation Y. So we found, or we pulled out the values based off the index. Now, the thing about this is if you are using this in your code and you're like coming back to it, you're like, what is generation group dot 0? That makes no sense whatsoever. And it doesn't. If you're looking at it, you have to remember, okay, what was an index 0 again? You know, the thing is one way to make this a lot easier to see and to work with is to actually give the index a name. So the way we do that is we basically give it a label. So instead of just birth year, index 0, let's give it a name. Let's call it year. So it's the label you want, colon, and then the variable in the tuple. And then generation, let's just say generation. And then colon, generation string. Alright, so how do we access this? We use the name. So same thing with indexing. Instead of using 0, we actually will use the name that we set, which is year. And sure enough, 1994 appears. So it responds, it's almost exactly like using 0, but we're actually using something that's readable and that we understand. So generation group, generation, and boom, generation Y. So there you go. So that's one way you can access and use tuples, which is pretty awesome. All right, so the next thing I wanted to cover is pattern matching. So say you have a tuple and you're trying to figure out, does this tuple have the value I'm looking for? You know, so let's dig in to see how pattern matching works. So say you have a year that you're like, I want to know if this year exists in this tuple. What we can do is we can actually pattern match. And we do that with using switch statements. So let's see here. Let's go ahead and create some constants here. So say we have a first birth year equal to 1985. And then I'm going to see if, let's see, I have a second birth year. Have that equal to 1995. And let's create a tuple. And we're going to say the birth years equal to, and then we say first birth year, oops, and then second birth year. And then let's create our switch statement. And we want to check the birth years, the tuple. And then these are little brackets. And then we do our case. So let's say we are looking for 1995. So how you do that is you say, okay, 1995, does it occur in the first and the second spot? And if it does, print out and I'm going to do birth years is found in both I'll do indexes. Okay. we do case, and this is where it gets interesting. We use an underscore, and basically an underscore is a wild card, so it will match against anything at all. It doesn't matter. So we're going to do underscore 1995. So this, we're seeing if it appears in the second index. Oops. Oops. Oh gosh, wrong button. So colon, important to get that colon. All right, print, and then I'm just going to just copy this over, just make it easy. Copy, and then birth year is found in second index. Okay, and then we're going to do case. Now I'm going to see if it's in the second or the first index, right? So we already checked the second. And then call, and then wildcard, colon. I'll just go ahead and copy this. Paste. I'm going to say first index. And then we have one more case where it doesn't match anything. Actually, we're just going to do a default because we've already checked for both the first and the second index, the first and the second. So, yeah. So then we'll print the birth years. It's not found at all. All right, so let's see what happens. Okay, so as you see, well, we are looking for 1995, and it says that it's found in the second index, which is true. It's absolutely found in the second index. Say if we had both. It's found in both indexes. Which is absolutely accurate. It is. Let's say we don't have either. That should output, no, not found at all. Yep. It's not found at all. So, yeah, very true. I'm actually going to delete this because that makes more sense. But I just kind of wanted to show you with me pulling the tuple into the string, you can see, okay, yeah, it's definitely in there, or no, it's definitely not, because it's nice to see when the output actually outputs what you're looking for. All right, so there you go, that's pattern matching. I'm trying to see if there's anything else I'm missing here. Oh, I forgot to mention value binding, which is great, because value binding, which I was doing actually just a few moments ago, I'm going to do that, where I'm binding the value, where basically value binding, what it does, it binds the matching value to a certain case to a local constant or variable to only use within that case. So as you've seen, I was pulling birth years out so that you could see, you know, okay, yes, it does equal that. So if I change it back to 1995, you see it pulls it in, and only to be used in just that case. So there you go, that's value binding. All right, so we've covered quite a bit. We've covered switch statements, like there's no tomorrow. We, experimented a little bit with the where statement. We've discovered the awesomeness of tuples, named indexing, which makes, pulling the values from tuples much more easier because it's readable. And then we did some pattern matching where we're looking for a value where it appears in a tuple index. So there you go. And I hope you enjoyed learning about conditional statements, if, else, switch, like I did. All right, till next time. Okay, I just wanted to point out that I actually did make a mistake up here in the where case. The where case is actually not supposed to be greater than, it's actually supposed to be less than, and then unknown year is, I believe, supposed to be greater than, because then that will catch anything that's above 1995. Yeah, because I think if you put in how I had it before, actually includes the years that we actually have in here, or that we've accounted for. So just wanted to make that correction, that there was a logic error in the where case. And then I wanted to show you that value binding using an index. So here, instead of having Earth years without the index and having both of them print out, you can actually say, okay, an index, the first index. In this case, it's both. So we could do and then value bind the second index, so birth years, and then dot one, so years, and then that will pull in both the values in both the first and the second of the tuple, and then here we can actually put in what the second tuple was. So to copy that, because that's the first tuple, the second tuple, and then we can copy this again for that, for the first one, and then we can play around and see that, yeah, this is actually true, and 1995 is found in the second tuple. So that's value binding with tuples. And then if you wanted to value bind somewhere else, or like for example up here, we have generation Y, so we say, well, what was the year that we inputted? We can actually do value bind here as well. So value binding birth year. So we can see that, yeah, the birth year was 1994. Okay, so just a really quick correction